Hi everyone, welcome back to another video of Ethereum Basics. In this video, we'll compare Web2 and Web3. So Web2 refers to the version of internet that most of us know today. All of these applications like Twitter, Facebook, Google, these come under the umbrella of Web2. And basically these services make up an internet that is dominated by the companies which take our data and provide some services. We use all of these services for free, but actually we are the product ourselves. On the other hand, Web3 refers to decentralized applications that run on blockchain. These are applications that allow anyone to participate without monetizing their personal data. So, blockchains are designed in such a way that your real identity is often not there on the network. You are just interacting with the dApp using a public key. So, there's very little scope of monetizing the personal data. But again, like capitalism, they'll find some way or the other. What can we do? So, coming to the benefits of Web3, anyone who is on the network has the permission to use the service, as simple as that. There's nothing prohibiting you from joining the network or using the dApps. You can just create a wallet on your browser and you can start using the dApp. The only thing that would prevent you is poverty, like you cannot buy enough tokens to try out the dApps. Other than that, there's no other thing stopping you. Then no one can block you or deny you the access to the service. If you are trying to use a service, mostly you will be able to use it. Another huge advantage of Web3 is that payments are built in using the native tokens. So imagine using HTTP protocol and all of the data is transmitted via the protocol. Similarly, with blockchain, the concept of assets, which could be anything, tokens, NFTs, real world asset, anything, the concept of assets is baked into the infrastructure itself. So that is a very huge advantage in a way that the infrastructure is specifically designed around assets. So you have a lot of things that you can easily do on Web3 infrastructure as compared to Web2 infrastructure. Ethereum is Turing complete, meaning you can program pretty much anything. And if you are bad at programming, you can pretty much clog the network completely. But again, not trying to get personal here. Here are some examples that compare Web2 with Web3. For example, in Twitter, now known as X, they can censor any account or tweet. Too many jokes there, but yeah. So Twitter can censor any account or tweet, but Web3 tweets would ideally be uncensorable because there's no one controlling the network. Or if there's a DAO, you would have an entire process of content moderation in a decentralized way where everybody would vote that this is not appropriate. So ideally that should happen. The reality here is yet to unfold. In Web2 services, especially financial services, payment service may decide to not allow payments for certain types of work. We know what kind of work we are talking about here. But Web3 payment apps require no personal data and cannot prevent payments. Servers for gig economy apps can go down and affect worker income. In Web3, servers cannot really go down. Web3 is based on a decentralized network of thousands of computers. So the theoretical principle here is that there's a single entity that is running a service that can go down because of multiple reasons. But if you have a decentralized network of nodes running a particular service, it is much harder to take it down. In theory, that is the main difference between a single entity operating a service and a distributed network operating a service. So where there's benefits, there are also limitations. And honestly, at this point of time, we have more limitations in Web3 than we have benefits. The benefits are only there in principle, and most of them are yet to materialize. So that will depend completely on how we are able to tackle the limitations. So it's on us, guys. Build more dApps and solve these limitations. So one limitation is scalability. The transactions are slower on Web3 because they are decentralized. A simple payment needs to be processed by a node and then propagated throughout the network. Very simple example of this is Visa and Mastercard processes 20,000 transaction per second, while Ethereum has the capacity of 15. Some other layer 1 blockchains claim more, but they are down many times, so that's a different thing. The other limitation we have is user experience. Web3 user experience is very bad. So it is a very fundamental human behavior that once you are used to a certain kind of convenience, you won't go back for any reason unless and until it really makes a difference for you. So people who are used to services like Venmo and Google Pay, they are not going to install MetaMask wallets or buy hardware wallets just so that they can do transactions in a decentralized way using some crypto tokens. So yeah, interacting with Web3 applications usually require extra steps, software, hardware, and education. You can easily lose your seed phrase and lose all of your money. Many people have lost their hard drive and many bitcoins on them. So that is a very huge hurdle to adoption. Other two limitations are accessibility and cost. So since Web3 is an emerging technology, it is not yet completely integrated in modern web browsers, and this automatically makes it less accessible to more users. If you compare the users of Chrome versus Brave, you'll have an answer there. And cost, dApps are very costly. If you want to store anything on blockchain, it's very, very expensive. That's why projects like Aviv and Filecoin are there, so that they can provide a cheaper way of storing data in a decentralized way. But if you want to store even a few MBs of data on Ethereum, it would cost you a lot. So most successful dApps only put a very small portion of their code on the blockchain, as much as it's necessary, just because it's very expensive. Before we wrap up, we'll do a quick comparison of centralized and decentralized networks. So, in centralized networks, the network diameter is low and the information propagates quickly because all of the participants are connected to the central authority. While in a decentralized network, the information broadcast from one side of the network to other side of the network may take a long time because it has to go through multiple nodes. So you can see it in this diagram. We have a centralized network and we have a decentralized network. Uh, Here, if you want to transmit an information, it will go from the center of this network to the edge all at once because the information has to travel to one node only. And in a decentralized network, if you want to transmit an information from one node to other, it will pass through many nodes. The next comparison is that centralized networks usually have higher performance and are easier to implement. They give higher throughput and usually require less amount of computational resources for providing that throughput. Decentralized network usually have a lower performance and they are more complex to implement. They need a lot of computational resources to provide a lower throughput. So again, that could be a big L for decentralized networks. But do keep in mind that there are other aspects of decentralized network that have a positive side. So again, everything is designed for certain use cases, and at certain places you might want to compromise on throughput and the complexity just so that you can achieve some other quality of the network. In centralized networks, whenever you encounter conflicting data, centralized authority can clarify it because that is the ultimate source of truth. While in a decentralized network, since there's no centralized authority that can dictate that, yes, this is true and this is false, all of the nodes would need to work together and they would need a protocol which is often very complex to implement to help them arrive at a consensus that what is true and what is false. In centralized system, it's very obvious that we have a central authority which has its benefits, but again, it could be a single point of failure. In decentralized network, there's no single point of failure because the authority is distributed among various nodes. In centralized systems, the coordination among participants is easy because the central entity is there. They will dictate and guide the communication. In decentralized networks, the coordination is difficult. The network participants need to follow a consensus mechanism and reach a consensus. Centralized networks have a risk of censorship. The data and its movement can be restricted. In decentralized networks, censorship is much harder because the information has many ways to propagate. For example, if someone wants to censor information, They just have to talk to the central authority in a centralized network, and they'll block the information from being propagated in any way. But in a decentralized network, the information can propagate in any way, and one or two nodes cannot really stop the information from propagating. Then ultimately it comes down to the consensus mechanism, that how many nodes have received that information and how many nodes end up arriving at a consensus on what information is true and what is false. The last point of comparison is that participation in the centralized network is controlled by the central authority, so they are permission networks, while a decentralized network is permissionless. Anyone can participate in the network and there are no gatekeepers, and the cost of participation is also very low. Now, before I close this topic, note that centralization versus decentralization is a spectrum, and no network is entirely centralized or decentralized. So, if we take Ethereum for an example, if most of its nodes are being run on a cloud service like AWS or Azure or GCP, again, you have a risk of centralization there. So it's a spectrum. No network is completely centralized or decentralized. Even the term decentralized is also a slightly debatable topic. There's this article by Vitalik himself, written in 2017, that elaborates more on the meaning of decentralization. So the general confusion is there that whether this kind of network is a decentralized network or is it a distributed network. So there are some conflicting diagrams, and Vitalik here in this article tries to explain exactly what is decentralized network. Now there's a lot of explanation here, and he talks about a lot of valid points, obviously because he's Vitalik. But yeah, do you can check it out. You can search it on Google. It is actually a very good read. So that was all about Web 2 versus Web 3. And with that, this part of our Ethereum series, Ethereum Basics, comes to an end.